Hello and welcome to the presentation and debut of the Wildlife Crossing Calculator. My name is Graham Porter. I'm a graduate student researcher at UC Davis. I'm part of a team including Fraser Schilling and Dave Waitchen, both part of the UC Davis Rhodocology Center, alongside Julia Kinch at Eco-Resolution and Dan Smith from the University of Central Florida. And now a brief project overview. The Wildlife Crossing Calculator, or WCC, is a decision support tool to help estimate the cost to the public of crashes involving wildlife and compare them with the costs and benefits of wildlife crossing mitigations. The WCC results in crash cost analysis that provides the annual cost per mile of crashes, including both the vehicle and wildlife losses. Outputs of the WCC include interactive maps of economic losses and statistical hotspots, as well as graphs of economic value from implementing mitigation. Our goal with this project is to produce a reliable tool that DOTs can turn to for planning where and how to most efficiently mitigate wildlife vehicle collisions. Next, some background for this project. Wildlife vehicle collisions, or WVCs, cause extensive ecological and economic harm. Collisions with large mammals can cause property damage, injury, and even death of drivers, passengers, and the animals. These identifiable outcomes of collisions have equivalent financial costs. Mitigating WVCs involves building structures and devices with known efficiencies and costs. Bringing all these attributes together mean that the various costs of WVCs can be compared with the cost of mitigating them. Our target audience for this project are the state departments of transportation, transportation ecology researchers, or just anybody with a few $1 million to spare and the rights to build a mitigation solution, just like you. And now, let's try to understand the problems we're trying to solve with this project. First, mitigating WVCs is still seen as an environmental problem by many instead of an economic one. Number two, while the literature for analyzing WVC's patterns is rich, no open and free tool exists for DOTs to use and easily conduct spatial analyses on their own crash data. And lastly, there is currently no open and readily available tool to compare the benefits of reducing WVCs with the cost of mitigating them. But what exactly is the Wildlife Crossing Calculator? The WCC is a combination of R, a statistics programming language, and Drupal, a free and open source web content management system. RStudio and R scripts built within it act as a back-end logic processing layer used to intake user input and conduct analyses. They also handle data cleaning, transformation, and they create graphic outputs for use in the front end. Drupal then acts as the front-end user interface layer to provide users a comfortable and easy format to upload and explore their data. It also handles user inputs and the presentation of graphic outputs from the R scripts. And now, a little bit about the development process. We worked with 5 states: Arizona, Idaho, Montana, Oregon, and Wyoming. We iteratively developed a web system to analyze crash costs, define project areas, calculate mitigation costs, and calculate benefit cost comparisons. We carried out multiple familiarization sessions with state DOT and Fish and Wildlife staff, and used their feedback to improve our system.
Now, let's check the tool out. Let me formally introduce you to the Wildlife Crossing Calculator, the next generation of free and open wildlife vehicle collision and mitigation analysis tool. This is the home page, which connects you to all parts of the analysis process. In the center is a map, which shows all of your saved project areas and their info on the right for quick reference. Below this is the Help section, which details the workflow of the Wildlife Crossing Calculator. The steps present here correspond to the Workflow menu on the left. Let's begin using the WCC by exploring the data you will upload. Under the first step, you can upload shapefiles of crash data that must include the year, cab code, crash severity code, and the animal involved. Road layers and mile segments may also be uploaded, but default layers are included depending on your state choice during account creation. After uploading data, we can configure the values we'll use for crash cost, both vehicle and wildlife, along with mitigation structure costs. Default values are available for crash costs and wildlife values based on Federal Highway Administration policy and state restitution values, respectively. Default values for mitigating items are extracted from real project costs for multiple states. While these values act as a default option, custom sets of values are easy to put in. Take vehicle crash costs for example. Here, we can effortlessly create a new set of CABCO values. Pre-populated costs of the defaults are included for reference. Give the group costs a name. Change any values. And click Save. Now you have your own custom set of crash values to use for analysis. Easy as that. New mitigation items can also be added. Give the structure a name. Pick a type. A unit cost based on the type, so square foot for this overpass that we're building here. Lifespan. Then an annual maintenance adjustment, which is a percentage of the total upfront cost of the structure that's paid every year. And finally, the mitigation efficiency, or what percent of WVCs are expected to be mitigated. Hit Save, and you have a new mitigation item. Now we can move on to our first analysis, calculating the crash costs. You can name the crash cost something unique for later. Then select the inputs you would like to use from your uploaded crash data, your road layer, the crash costs you used to use, both for vehicle and wildlife. Here we see the first major output of the Wildlife Crossing Calculator. An interactive map detailing the annual crash cost per mile, as well as the statistically significant hotspots. You can zoom in on any road segment to view the annual crash cost and the number of incidents for that mile segment. You can also download the results as a shapefile for offline use. Next, we want to choose an area for our mitigation project to service. You can do so by clicking Define Project Area. Here, we can pick the polygon or box tool and simply draw a polygon around the roads in which our mitigation project will service. Give the project a name. Hit Save. And we're ready to obtain the crash costs associated with that area. Click on Compute Costs under any of your chosen project areas that you've created, and the total cost under that area will be automatically calculated. Now that we have the crash costs associated for this project area and they're ready to be mitigated, let's build some mitigation. Click Mitigation Cost Calculator to begin. To calculate the mitigation costs, you must first choose the project area, and then add any number of mitigation options. Here we have an overpass. We'll say it's 200 feet long. and 70 feet wide. And then fencing, we'll say we have about 5 miles on each side, so 10 miles in total, give or take 60,000 feet. We'll add some escape ramps. You can change the effectiveness of the entire solution if you want, and then run analysis. This is an example of the output, which gives the total upfront as well as annual maintenance costs, seen here. Last, we can run the benefit cost analysis to see if our mitigation solution is an economically feasible one. Select Run Benefit Cost Analysis to get started. Change the name if you wish. Select the project area costs, and then select up to 5 mitigation solutions for comparison. Change the discount rate if you want, but note that this is an especially sensitive variable. The escalator will increase your upfront cost by a flat percentage to represent unforeseen costs, but defaults at 0%. Click Run, and an interactive graph of project value will populate. Because the costs are already considered for this calculation, where the colored curves cross the black horizontal line, indicates where the mitigation solution breaks even on the investment. The final value on the curve indicates the net present value of the project, or the total value in today's dollars that the investment represents. This tool allows for easy navigation through the analysis of WVC data and mitigation comparison, and has provided a simple solution to the problems WVC mitigation faces today.
Now, let's look back at those problems we discussed earlier. Number 1, mitigating WVCs is still seen as an environmental problem by many instead of an economic one. Well, not anymore. With the Wildlife Crossing Calculator, we now incentivize viewing WVC mitigation as a solution to economic losses. And number 2, there is no open and free tool that DOTs can use to easily conduct spatial analyses on their own crash data. Well, again, not any longer. The Wildlife Crossing Calculator provides an easy and free tool for DOTs to conduct spatial analyses on their own WVC data and act as a decision support tool. And finally, there's also no open and readily available tool to compare the benefits of reducing WVC with the cost of mitigating them. Again, no more. The Wildlife Crossing Calculator provides an easy and free tool for DOTs to compare the benefits, cost, and lifetime value of mitigation. Some next steps. We want to make sure the system is available to other interested states and organizations, and also assist them with the use of the tool. We want to make improvements to the system as it's used and more feedback is gained. We want to conduct retroactive tests of existing wildlife crossing structures to test whether their implementation has altered the pattern of WVCs in the surrounding area. And finally, we want to include values from non-WVC events and barrier effects on wildlife populations and integrate them into the benefit cost analysis. I'd like to acknowledge the Departments of Transportation and Fish and Wildlife from our partner states for their feedback throughout the development process, as well as the Pew Charitable Trust and their staff for their intellectual involvement. Thank you for listening to the presentation and debut of the Wildlife Crossing Calculator.